Anyway, I made some revisions to the homework, the problem sets. So, if you want to see the revisions, you have to close and then reopen the website. Basically, I removed problems, so you have less to do now. Because I was sensing a weakness. So after 20-something years, you got less problems than all the other years. Congratulations. And then for the quiz, I noticed, like I told you guys, number one, you knew the problem, and I'm walking around the room like so many people like playing. All you gotta do for the quiz is like just whatever the homework problem is. I mean, I just changed the numbers. That's how you do the quiz. You just gotta remember how to do the homework problem. It's the same thing. It's exactly the same thing, except with the number change. I copy, I paste, I change the number. That's how I write quizzes. Okay, last night we did quadratic functions, right? But it's easy to write the equation of a quadratic function if you know the vertex. What if you don't know the vertex? Like, well, if you have three non-collinear points like this, you could give me some 3 points. 1, comma, 3. 2, comma, 1, and then 4, comma, 5. Okay, these are 3 non-collinear points, right? 1, comma, 3, 2, comma, 1, 4, comma, 5. Right? Didn't we learn last year? If you have 3 non-collinear points, there is exactly one parabola that goes through them. Yes. Okay, so tonight's homework, write the equation of that parabola. Now, do we know if any of these points is the vertex? No, in fact, I don't think any of these points is the vertex, so you do not use vertex form. So what form should you use then? This one. Ah. And why do the points have to be non-collinear? Because if they're on a straight line, how can they be on a parabola? Right? So what do you think we're going to do? If this is the equation we're going to do, and I tell you this graph, which is a parabola, passes through these 3 points, what do you think we're going to do with these 3 points? You're going to plug it in. So you're just going to plug in each point one by one. Okay, let's see what we get. So if I plug in 1 for x and 3 for y, what do I get? Oh gosh. A plus b plus c equals 3. I like to put the number on that side, because that's how you're used to seeing it in algebra 2, right? Okay, plug in this point. Plug in 2 for x and 1 for y. Plug in 2. 4a plus 2b plus c equal 1. And then finally plug in this point. 16a plus 4b plus c equals 5. Everybody see what I did? And now what do you think you're going to do? Yeah, you just solve those equations. And once you solve these equations, I'm not going to do it just to save time, but once you solve these equations, that'll tell you what A, B, and C are, and there you go. That's the equation of the parabola. So the first 3 problems on tonight's homework, that's what you're going to do. Just plug in the 3 points into this form of the parabola and solve 3. And that's why, when you have 3 equations, 3 variables, you have to be able to, like something like this, it should not take you longer than a minute. Here, just do this. Look, take these 2, subtract, go, subtract. Go, this minus this. 3a plus b equal -2. Now do these 2, this minus that. 12a plus 2b equal 4. See, now you've just got 2 equations, 2 variables now, right? Right? And then if I were me, I would divide this equation by 2, so you get 6a plus b equal 2. And then now take these 2 equations and subtract. This minus this, go. This minus this. 3a equal, no, this minus that, 4. Therefore a equals 4/3. Now normally I don't make my answers come out ugly like that. I'll make it come out to integers, but I just made up these numbers. And then once you get a, plug it back into one of these to get b. Once you got a and b, plug it back into one of these to get c. Probably this one's the next one. But you have to be able to solve 3 equations, 3 variables in this class quickly. Okay, now one of the other problems on tonight's homework is I'm going to give you some data points. This is science, right? Something like this. Let's say you're doing an experiment and you're plotting the data points and you get something that looks like that. Now, if you want to, you can write the best fit straight line that goes through these points here, but does it look like the even line on a line? No. So then you can write best fit parabola. So you do exactly the same thing with the best fit straight line. You put all the points in, but instead of selecting linear regression, what do you select? What do you think? Quadratic regression, because it's a quadratic function. And we're going to, every time we come across new functions, we're going to do the same thing. Just like later on this quarter or this semester. What if the points look like this? You do an experiment and the points look like that. What does that look like? Yeah, you do an exponential regression because it looks like an exponential function. You don't do a linear regression if it doesn't look like it lies on the line. And one of the most important things on tonight's homework, do you know that you can solve any equation on your calculator? Any equation. That's probably the most important thing your graphic calculator can do. It can solve any equation. Okay, so what if I give you this equation? It looks very similar to the one you got tonight, or the example I have in there. Solve this equation. Solve. Okay, practice. Take out your calculator. 2 to the x, since you guys don't look at the thing, equals 1.1 x squared. I think the example I did on your notes is 2 to the x equals 1x squared. I just changed it to 1.1. How do you solve any equation on your calculator? Well, what you do is you make one side 0, like this. You don't even think. Just make one side of the equation 0, and then you graph this right here. You graph this on your calculator. So if you're on the Prism, go into graph mode and graph this. If you're on a TI, press the Y equal button and punch this in. I guess you would punch it in like this, huh? 2 raised to the x power minus 1.1 x squared. And then you graph it. Okay, what does the graph look like? It kind of looks something like this. So how many answers are there? Looking at this graph, how many answers does this equation have? 3. 1, 2, 3. The x-intercepts of this graph are the answers. How come? Because you're trying to find when this thing is equal to 0. And if you graph that, you want to know where is the y-coordinate equal to 0. And where is the y-coordinate equal to 0? At the x-intercepts, right? So, now this is where a Casio is way faster than a TI. If you're on a Casio, how do you calculate these x-intercepts, or we'll call them zeros? You just press G-solve, since you guys are not looking at the thing. G-solve. Do you have a G-solve button? Okay, now press G-solve, F5. Root, select root, which is F1. Press that, F1. Whoa! Then the calculator gives you the coordinate of this. Which is, what is this? Give me 3 decimal places. Point, Manago. Negative 0.7 something, right?
0.738.
Everybody got that? And then you know how you find the next one? Just press the root button again. Or press the right arrow. You press the right arrow? Okay, press the right arrow. 1.7 what? 46, and then one more time. Quick. Okay, wait, you have a TI, that's why, right?
Yeah.
Okay, what's this one?
4.436.
Okay, there you go. Those are your 3 answers. You can solve any equation on your calculator. It's so simple. Now, for those of you with TI, this is what you got to do. You got to calculate. Look on the top. Second, calculate.
Yeah, I couldn't even get the...
You couldn't even get the graph? Did you punch it in exactly as I have here?
Yeah, I did.
If I come over there and you didn't, you're grounded.
I cleared it.
That means you did it. 2 raised to the x. What is that symbol?
Because I can't get
You're in polar mode.
Look.
You're graphing polar functions. Wait, who used that calculator?
Me. Oh no.
Because you were intrigued, that's why.
Yeah.
Okay, go back to function mode.
Is gonna be messed up.
No.
Okay.
See? And then you're in degree mode. That's like 2 strikes right there. You should be in function mode and radian mode. Oh my lord. Okay, how many people have TIs? How come so many people have TIs when Iolani recommends the Casio? This is what I want to know. A likely story. Okay, anyway. Okay, now you're in function mode.
Yeah.
Oh gosh. Okay, when you get this graph on the screen, okay, the bell's going to ring soon already. Okay, how do you calculate this one? Second, calculate and select 0. Then the calculator says left bound. Using your left and right arrows, move the cursor somewhere to the left of that point. Anywhere to the left of that point. Then press enter. Then it's going to say right bound. You move the cursor somewhere to the right of that point. Press enter again. And then it says guess. Do not guess. Just press enter again and you should see negative 0.738. And then you got to do the same thing for the other 3. That's why Casio is faster, yeah? And then I wanted to show you how to do this in the Pocket Cast on your iPad. It's even faster. Here, you guys can practice this at home on your iPad. You draw the graph, and then if you want to find its x-intercept, you know what you do? You just put your finger here, boop, and it pops up. You put your finger there, boop, and then you put your finger there, boop. It's even faster. Good thing we went to Plan B. Looks like we're going to have a lot of questions tomorrow. We're in a heap of trouble.